Good evening, students. Are you able to hear me? Am I audible? Board is clear. Students, am I audible? Is the board clear? Okay. What was the last numerical which we did in the last class? I guess logarithmic differentiation is what we had done in the last class. Right. We had done logarithmic differentiation. Let's do next, which is we call it as implicit function. Okay, the function can be implicit or it can be explicit function. What is the difference between an implicit function and an explicit function is? And explicit function can be expressed something like this: x in terms of y or y in terms of x. Suppose I am writing y is equal to sin x plus e raised to x, or suppose I am writing x is equal to say sin y plus e raised to y. If I am able to express x in terms of y or y in terms of x, then it is called as an explicit function, where you can express x in terms of y or you can express y in terms of x. But there are certain functions where whatever you try, you will not be able to separate x from y. Suppose I am writing now, if you do simplification also, expressing x in terms of y or expressing y in terms of x becomes difficult. Okay, so in that case, we call it as implicit functions. Okay, if your internet speed is low, then also you will not be able to see the board. Okay, I cannot do anything in that. Now, what am I saying is, where you are not able to express x in terms of y or y in terms of x, then it is called as an implicit function. And if you are able to express x in terms of y or y in terms of x, then it is called as explicit function. So, whatever numericals we have done up till now were of explicit function. Everywhere I used to write y is equal to something, y is equal to something. So we were directly able to get the value of dy by dx. Now in such cases where you cannot write y in terms of x, okay, in that case we have to find out, okay, the value of derivatives. Now it is not difficult at all. Don't worry, it is not you have to do something different from what you have done up till now. The things are going to be similar only. You don't have to do anything different. Okay. Let's see. So we have something like this: y cube plus cos xy is equal to x square minus sin of x square. Now I want to take the derivative of this. Okay, I want to take the derivative of this. So not a problem. You don't have to worry if you are not able to convert x in terms of y or y in terms of x. We'll apply the chain rule and our work will be done. So what will be derivative of 3y? I am going to differentiate with respect to x. So on differentiating with respect to x. So I will write d dx of y cube plus d dx of cos xy is equal to d dx of x square minus d dx of sin of x plus y. Now here I am differentiating with respect to x and this is the variable, therefore The derivative will be 3y square, but again I will have to take derivative of y. Okay, what I'm doing is I'm just applying the chain rule, nothing else. First, I took the derivative of y cube, considering as x raised to m type, and then again I took the derivative of y, because the formula was for d dx of x raised to n, but here we have d dx of y raised to n. Okay. Then derivative of cos will be minus sine. This will give me minus sine xy into derivative of x into y. Is equals to derivative of x square, that will give me 2x, derivative of sine of x plus y, so that will again give me cos of x plus y into d dx of x plus y. So here I will get 3y square dy by dx plus minus, that will give me minus sine of x into y into here u into v will x, then derivative of y plus y derivative of x. Derivative of x, that will be 1, derivative of y, that will be dy by dx. So here I get 3y square dy by dx minus, I multiply this inside, so I'll get sine xy into x into dy by dx plus y, dx gives it cancel, so 1 into sine of x into y plus minus, that will give me minus, is equal to 2x minus cos of x plus y minus dy by dx into cos of x plus y. So multiplying cos of x y. Now I want to find out dy by dx. So this term, all dy by dx on one side and all the other terms on another side. Okay. So here I get 3y square dy by dx minus sine of xy into x into dy by dx. This is minus, here it will come to the come plus dy by dx into cos of x plus y is equal to 2x minus cos of x plus y. This is minus, here it will come to the come plus, that will give me plus y into sine of xy. So now I will take dy by dx common. So I will get 3y square minus x into sine of xy plus cos of x plus y is equal to here 2x minus cos of x plus y into sine of xy. This term I will take down, therefore I will get dy by dx is equal to 2x minus till where you are able to hear. Till where you are able to see. Students, are you able to hear me? Are you able to hear me? Reply me. Are you able to hear me, students?
Yes, sir.
Able to hear me? Till where you were able to see that? I also did not realize when it suddenly there was an internet issue when it go. Here, what I did after that is I took the derivative by applying the chain rule everywhere. You don't have to worry in implicit functions. Everywhere you have to take derivative as a chain rule. Okay. So when you take derivative as a chain rule, then dy by dx comes on one side. अरे यार, कौन सा यार? There is lot of internet issue today, I guess. Now am I audible now? Am I audible now? Okay. So I was saying that when we have implicit functions, we don't have to worry. We don't have to do anything new. We have to take the derivative by applying the chain rule. Then all dy by dx comes on one side and all the other terms on the other side. So that is what I did over here. Okay. After applying chain rule and taking the derivative. Okay. After applying chain rule and taking the derivative. Okay, I took all the dy by dx terms on one side. As you can see, all the dy by dx terms on one side and all the other terms on the one side. Then I took dy by dx common and then this term over there. So finally I got the value of dy by dx as 2x minus cos of x plus y sin xy into upon 3y square minus x into sin of xy plus cos of x plus y. So this is my final answer. So even if it is implicit function, we always have to find out the value of dy by dx. Okay, and we get something like this. Finally, you all have to make dy by dx is common and you get this answer something like this. Okay, hope everyone has understood. So please take the screenshot of this. Okay, done. Everyone has taken the screenshot. Let's do next numerical. So here I have now x raised to m into y raised to n and this raised to x plus y raised to m plus n. Now again this is implicit function only because you cannot write x in terms of y or you cannot write y in terms of x. Okay. At the same time you have powers also. You can take log and you can solve and you can also do it without log. It's your wish. I'll go for log because I think it will make my life easy. So log of x raised to m into y raised to n is equal to log of x plus y raised to m plus n. Okay, so now log of m into n is log of m plus log of n. So this will become log of x raised to m plus log of y raised to n. And here the power will come down, log of x raised to n is m into, so this will become m plus n into log of x plus y. Okay. Now here also the powers will come down, so this will become n log x plus n log y. Here is equal to m plus n into log of x plus y. So now the things have become very simple for us. Now we'll take the derivative with respect to x. So m derivative of log x is 1 by x, n into derivative of log y is 1 by y into dy by dx. Why? Because they are differentiating with respect to x. Hence, so m plus n is constant, it will go outside the derivative. Our derivative of log is 1 upon x plus y into d dx of x plus y. So here I'll get m by x plus n by y into dy by dx is equal to m plus n upon x plus y into derivative of x is 1 and derivative of y is dy by dx. So I'll get m upon x plus n upon y into dy by dx is equals to m plus n upon x plus y plus m plus n upon x plus y into dy by dx. So all the dy by dx comes on one side and all the other comes on another side, and therefore here I get n by y dy by dx minus m plus n upon x plus y into dy by dx is equal to m plus n upon x plus y minus m upon x. Okay, so I'll take dy by dx as common, so I'll get n upon y minus m plus n upon x plus y is equals to, here also I can take LCM, so m plus n into x minus m into x plus y the whole upon x into x plus y. Same thing I can do here also, I can take LCM, therefore I'll get dy by dx is equals to n into x plus y minus m plus n into y the whole upon y into x plus y. Here I'll multiply into it, so this will give me mx plus nx minus mx minus my the whole upon x into x plus y. So this x plus y and this x plus y will get cancelled. Similar kind of calculation will get here also. I'll get dy by dx into nx plus ny minus my minus ny the whole upon y. And here which term is getting cancelled is mx, and mx is getting cancelled. I am getting nx minus my. I am getting nx minus my upon x. Here also my ny and ny is getting cancelled. I guess here I am having nx, ny. Okay. Here ny and y is getting cancelled, and here I get dy by dx into nx minus ny the whole upon y is equal to nx minus ny upon x. So I get dy by dx is equal to y by x into nx minus ny upon nx minus ny. Nx and y, and here nx, and nx plus ny. Okay, so this is our final answer. how we can do for implicit function. Just an idea we have taken of implicit function. Only we don't get derivative directly, so we have to first apply the chain rule and find out dy by dx on one side, other terms on other side, and we get the answer. So I hope everyone has understood. Okay, so everywhere, whenever possible, and to make our life easy, we can apply log, which I have done over here, because of which my numerical got easy. Okay, now let's see another numerical. Please keep on taking the screenshots, okay? We have lost a lot of time due to network issues today. Let's do next one. Y is equal to under root of tan of x plus 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 under root of tan of x up till infinity. So now how to do this? So infinite times I am going to add tan of x. Now what if you can see over here, what we have done over here is infinite times I am adding. Okay, under root of tan of x plus again under root of tan of x plus again under root of tan of x plus again under root of tan of x. How many times I am going to do? I am going to do infinite times. Now I have already explained you infinite as a concept and not as a number. So you add anything from infinite, even if you do infinity minus infinity, it is not 0. Okay, even if you do infinity minus infinity, it is not 0. So if I remove one term from infinite series, the value is not going to change. Okay, so even if I subtract one term, or if I subtract two terms from there, or if I add one term, okay, it is not going to make any difference when I am going to do addition infinite times. Okay, hence what I am doing is, you just see over here under root of tan of x plus. Now this is exactly this what I can write over here. Now instead of this, because this y is this only under root of tan x plus under root of tan x plus under root of tan x plus under root of tan x, that is what I am going to do again and again. The same thing I am going to do. Okay, I am infinite times. So if I remove one term or if I add one term, the value is not going to change. So what I did is, this entire thing, I removed this term and instead of this I wrote y over here. Okay, I hope it is clear to you. Now what I'll do, I want to remove square root. I take square. I know the directly square root is also there. That also we can do. It's not a problem. But I want to do this. So y square, that will give me tan of x plus y. Now I can take this term over here. So I get y square minus y is equal to tan of x. Okay, now I can take derivative. The derivative of y square, that will be 2y dy by dx minus this derivative of y will be only dy by dx is equal to derivative of tan of x is sec square x. Okay, so now I will take dy by dx as common. So what will remain here is 2y minus 1 is equal to sec square x. Therefore I will get dy by dx is equal to sec square x upon 2y minus 1. So this is my final answer. So at one moment this will look very complex to you, but we just apply fundamentals. We are through with the numerical. Okay, everyone please take the screenshot of this. Done. Okay, now let's go to next slide. that is derivative of a parametric form for the parametric equation. What is parameter? Okay, what is parameter? When we show some equations as a function of another single variable. Say for example, parametric equation for a parabola or for a circle is x is equal to 80 square and y is equal to 280. Sorry, this is for the parabola. Sorry, this is the parametric equation of a parabola. So what I did is x also I have written in terms of t and y also I have written in terms of t. So this t is called as a parameter. So now instead of writing y square is equal to 4ax, okay, which involves two variables, I am converting into a single variable, okay, by just giving a parameter t. Similarly, for the circle, we have x is equal to r cos theta and y is equal to r sin theta. Now we know that for a circle, radius is a constant value, it is not a variable. Okay, hence we have only one parameter now again. So instead of two variables as x square plus y square is equal to r. What is the advantage of this? So suppose if I the general equation, a standard equation of the circle is x square plus y square is equal to r square. If I put over here, then this will get a simplified or say is equals to say a square. Then what will become? This will become r square cos square theta plus r square sin square theta. So cos square theta plus sin square theta. So sin square plus cos square is equals to 1. So I'll get r square is equals to a square. So I'll get r is equals to a. Sorry. So the equation now, once we used to look little bit of complex, that is x square plus y square is equals to a square, became very simple, something like this. Okay, so that is the advantage of the parametric equations. So if I am showing two variables as a variable of a single parameter, then the equations are formed is called as the parametric equation. So how to take derivative of a parametric equation? Now don't by heart anything. We are not going to by heart anything. Okay, we are just going to understand. dy by dx. Can I write something like this? dy by dt into ddt by dx. So dt dx cancel, again I get dy by dx. Yes or no? Yes, we are not going to by out. Similarly, I can write like this also. dy by d theta into d theta by dx. So d theta gets cancelled. So again I get dy by dx. So dy by dx can also be written something like this. So we are just going to apply our head. We are not going to by heart any formula. So here in this case, theta is my parameter. In this case, t is my parameter. So whatever parameter is given in the question, that will write something like this. Okay, it's just an adjustment, nothing else. So I am not by hearting anything. Okay. So let's do one or two numericals on this also. So we get x is equals to cos log t and y is equals to log cos t. Okay, I want to find out the value of dy by dx. Okay, what I want to find out? So either if it is x in terms of y or y in terms of x, then it was very easy to find out dy by dx. So he has given in this terms. So we don't have to worry. Right now I just showed you. I can write this as dy by dt into dt by dx. So that is what I am going to do. So here also I have t, here also I have t, so I can differentiate it with respect to t. So differentiate it with respect to t, so I get dx by dt is equals to d dt of cos log of t. Here also dy by dt is equals to d dt of log cos of t. So I'll get dx by dt is equals to derivative of cos is minus sine. So minus sine log of t into derivative of log of t, that will be 1 by 2. Here dy by dt is equals to derivative of log is 1 upon x, so this will become 1 upon cos of t into derivative of cos of t is minus sine of t. So these values I will substitute over here. So I will get dy by dx is equals to dy by dt. So dy by dt is minus sine t upon cos t into dt by dx. What is dx by dt? I just write reciprocal. So reciprocal will become minus t upon sine log of t. So minus minus will become plus. Therefore, I will get dy by dx is equals to sine by cos is tan. So tan of t into t upon sine log of t. So this is my final answer. Okay, so this is the parametric equation. This is how we solve the parametric equation. Please take the screenshot of this. Okay, I hope everyone has taken the screenshot. Is my voice very much low or is it audible still? My voice is very much low or if it is audible? Okay, good. Let's do next. So we have here x is equals to a into theta plus sine of theta, y is equals to a into 1 minus cos theta. So this time the parameter is theta, so we'll take derivative with respect to theta. So I'll get dx by d theta is equals to a is constant will come outside derivative. Derivative of theta will be 1 and derivative of sine theta will be cos theta. Here dy by d theta is equals to a derivative of 1, that will be 0, and derivative of cos theta is minus sine theta. So minus minus will become plus. So I get dx by d theta is equals to a into 1 plus cos theta. And dy by d theta 0 plus sin theta is, so I will get a sin theta. Now I can write dy by dx is equals to dy by d theta into d theta by dx. So value of dy by d theta is a sin theta into value of dx by d theta. I have dx by d theta, I want d theta by dx. So I will take the reciprocal. So it will become a into 1 plus cos theta. So a gets cancelled, so I will get dy by dx is equals to, if you want to further simplify, you can further simplify. You can write sin theta as 2 times sin of theta by 2 into cos of theta by 2, and here 1 plus cos theta can be written as 2 times cos square theta by 2. 2 will get cancelled, 1 cos theta will get cancelled, so you will get tan of theta by 2. If you want to further simplify, you can further simplify it also. Okay, take the screenshot of this. Okay, I hope everyone is taking the screenshot. We have seen parametric also, few parametric numericals also we have seen. Now, next we are going to see derivative of a function with respect to function. Up till now what we saw was derivative of a function with respect to variable. Either I am differentiating with respect to x, or I am differentiating with respect to y, or I am differentiating with respect to t, or I am differentiating with respect to theta. But suppose I am saying that find out derivative of tan of x with respect to tan inverse of x. Okay? I'm telling you, find out derivative of tan of x not with respect to x, but this time I am saying you with respect to tan inverse of x. Then how you will do? So that is what I say is, okay, derivative of a function with respect to another function. So suppose I have something like this. Find derivative of 7 raised to x with respect to x raised to 7. See, both are different. Constant raised to variable, variable raised to constant. This time I am not differentiating with respect to x. So what we do is it's simple. I take one as u and I take other as v. So I am taking 7 raised to x as u and I am taking x raised to 7 as v. Now what he wants? Derivative of this with respect to this, which means u with respect to v, which means I have to find out, right? Now it goes little bit simpler. I want to find out du by dv. This is what it means. I have taken this as u and I have taken this as v. Derivative of u with respect to v. Okay, so I wrote du by dv. This is what we have to find out. Now, by just applying the knowledge of the parametric which we have already done, I can write, see here also I have x only and here also I have x only. So if I just apply the knowledge of parametric, I can just say that it is in the parameter x. Hence, I can write this du by dv as du by dx into dx by dv. Dx gets cancelled, I get one and the same. So now this numerical became easy and now it became in the parametric form. So we use 7 raised to x. So derivative of u with respect to x. So derivative of 7 raised to x, so we have formula 7 raised to x into log 7. V x raised to 7. So derivative of v with respect to x, that is going to give me 7x raised to 6. I'll just put the values over here, therefore I'll get du by dv is equal to du by dx, that is 7 raised to x into log 7 into dx by dv. I have this, so I'll have to take a reciprocal. That will become 1 upon 7 into x raised to 6. Okay, so this is 7 raised to 1, so this will become du by dv is equal to 7 into 7 raised to x minus 1 into log of 7 divided by x raised to 6. So this is my final answer. Okay, so this is my final answer. So I just apply the knowledge of parametrics, so such numericals will become easy. Please take the screenshot of this. Done. I hope everyone has taken the screenshot. Okay. Next, derivative of cos inverse of x with respect to 1 minus x square. So I take u as cos inverse of x, d as under root of 1 minus x square. By applying the same principle, my du by dx will become derivative 1 upon cos inverse of x is minus 1 upon under root of 1 minus x square. dv by dx, derivative of root x is 1 upon 2 root x, so that will be 1 upon 2 root 1 minus x square into derivative of 1 is 0 and derivative of x square will be 2x. Okay? So, I get dv by dx is equals to minus 2x. So 2 gets cancelled, so minus x upon under root of 1 minus x square. So therefore, my du by dv is equals to du by dx, so that value is minus 1 upon under root of 1 minus x square into dx by dv. So reciprocal of this, so under root of 1 minus x square upon minus x. So 1 minus x square minus 1 minus x square gets cancelled, minus sign gets cancelled. So I will get du by dv is equals to 1 upon x. So derivative of cos inverse of x with respect to under root of 1 minus x square is 1 by x. Take the screenshot. Everyone, I hope everyone has taken the screenshot. Okay, let's do one more. Tan inverse of root of 1 plus x square minus 1 upon x and b with respect to sine inverse of 2x upon 1 plus x square. So I have to differentiate this with respect to this. Okay, I want to differentiate tan inverse of under root of 1 plus x square minus 1 upon x with respect to sine inverse of 2x upon 1 plus x square. So again, everything will remain the same. Nothing is going to change. So now I take u tan inverse of 1 plus x square minus 1 upon x. If I directly take the chain rule and derivative, okay, I will be in a problem, so we will go for substitution. So whenever I have 1 plus x square term, I will always go for x is equals to tan of theta. So this will become u is equals to tan inverse of under root of 1 plus tan square theta minus 1 upon tan of theta. So I get u is equals to tan inverse of 1 plus tan square theta is sec square theta, and square and square root will get cancelled. So I get sec theta minus 1 upon tan of theta. So I get u is equals to tan inverse of sec theta can be written as 1 upon cos theta minus 1, and tan theta can be written as sin theta by cos theta. So now I will get LCM, so I will get tan inverse of 1 minus cos theta, the whole cos theta, right? So cos theta and cos theta will get cancelled. So I will get u is equals to tan inverse of 1 minus cos theta is nothing but 2 times sin square theta by 2, half angle formula, the angle will become half. Sin theta half angle formula can be written as 2 times sin of theta by 2 into cos of theta by 2. So 1 sin will get cancelled, 2 and 2 will get cancelled, so sin by cos is tan. So I get u is equals to tan inverse of tan of theta by 2. So So tan and tan inverse gets cancelled, so I get u is equals to theta by 2. So I want du by dx, so I do du by dx is equals to 1 by 2 d theta by dx. Okay? Or instead I can just increase one more step, and from here I can find out the value of theta as tan inverse of x. So here I can put 1 by 2 and theta is the thing, but tan inverse of x. So now I take derivative du by dx is equals to 1 by 2. Derivative of tan inverse of x is 1 upon 1 plus x squared. This is the value of du by dx. Next I want to find out the value of dv by dx. So I have d over here as sin inverse of 2x upon 1 plus x squared. Now again I cannot directly go for derivative, otherwise I will be in a trouble. So here also I am going to do a substitution. Remember one thing, whenever you have 1 plus x square tan theta. Sir, how to remember? It's easy. Derivative of tan inverse of x is 1 upon 1 plus x square. For cot inverse also it is minus 1 upon 1 plus x square. Hence, whenever you have the term 1 plus x square, you can put x is equals to tan theta or cot theta. Similarly, derivative of sin inverse is 1 upon under root of 1 minus x square. Hence, wherever it is 1 minus x square, you can put x is equals to sin theta or cos theta. Similarly, derivative of sec is x into under root of x square minus 1. So whenever you see the term under root of x square minus 1 or simply x square minus 1 or x into x square minus 1, okay, put x is equals to sec theta or cosec theta. Okay. Here I have, so I can put x is equals to tan theta, so I will get sin inverse of 2 tan theta upon 1 plus tan square theta. So you be very well know this is the formula for sin to theta. Okay. So I will get b is equals to sin inverse of sin to theta. So sin inverse will get cancelled, I get values to theta. So from here I get theta is equals to tan inverse of x, which can be written as 2 into tan inverse of x. So I get dv by dx as 2 into derivative of tan inverse of x is 1 upon 1 plus x square. So now I will substitute the value in equation 1. So I will get du by dx is equals to du by dv is equals to du by dx, which is 1 upon 2 into 1 plus x square into dx by dv. So opposite of this, reciprocal of this, so 2 into 1 plus x square. So I get du by dv is equals to 1. So derivative of tan inverse of under root of 1 plus x square minus 1 upon x with respect to sin inverse of 2x upon 1 plus x square is, the answer is on your board. Please take a screenshot. If anyone is not understanding anything, please ask me. Take the screenshot. आता चांगलं आहे, चार्ज करायला विसरलो मी. Everyone has taken the screenshot. Now we are going to move to the last part. After that, we'll see Okay. Everyone has understood? Taken the screenshot. Now last part, higher order derivatives. After that, we'll start with the previous exam problems. Previous years, last, 15, 20 years, problems will start. So what do I mean by order? So order means how many times am I taking derivative? This is why. So I can take derivative once, so I'll get dy by dx. Again I can take derivative of this. Okay. Then again I can take derivative of this. So I can do n number of times. How many times I want to take derivative, I can take the derivative. So if I take derivative only once, so this is called as first order derivative. Okay, denoted by f dash of x or y1. If I am taking the derivative for the second time, that is denoted by d2y by dx square. Okay, this is read as d2y by dx square. It is also denoted by f double dash of x or also denoted by y2. Now here I have taken the derivative third time. This two times I already had taken derivative. Now I am taking the derivative for the third time. It can be denoted by d cube y by dx cube, denoted by f triple dash of x, or can also be denoted by y. So this is called as second order derivative. This is called as third order derivative. If I keep on doing it, okay, I can take nth derivative also. It will be denoted by fn of x or yn, and this will be called as nth order derivative. So these are higher order derivatives. We do require to take the derivative when we take first derivative of displacement. Okay, just a minute. Just a minute, students. Today there is a lot of issues. Am I audible, students? Am I audible? Please respond me. Okay. We do require these higher order derivatives. When we take the first derivative of displacement, we get the velocity. When I take second derivative, I get acceleration. Okay, when I take third derivative, I get something called as impulse. Okay, what do I get? I get something called as impulse of a force. If I keep on taking derivative in the physics point of view also, I am going to get something. Why are we doing in this mathematics is, one thing you have to understand that mathematics of calculus came due to the physical problems which you were not being able to solve. There were many physical problems which we were not able to solve. Hence, whenever you are talking about the calculus, there has to be some or the other physical significance always. So I hope you understood why are we even interested in higher order derivatives. Okay. So now you know the notations also. I hope everyone would have taken the screenshot. Now we'll not waste much of the time. We'll directly go on to the numericals. Okay. So if I'm saying find second order derivative of y is equals to x square into e raised to x. What I need to find out? Second order derivative means d2y by dx square. So first time I'll take the derivative, so dy by dx u into v. So x square is constant, e raised to x derivative is e raised to x. Then e raised to x is constant, derivative of x square, that will be 2x. So I can take e raised to x as common, x square plus 2x. So this is the first order derivative. Now second order derivative, so d2y by dx square is equals to d dx of e raised to x into x square plus 2x. So again I can take this as u and this as v. So I'll get d2y by dx square is equal to e raised to x is constant, derivative of x square is 2x and derivative of 2x will be plus, this time I am keeping x square plus 2x as constant and I am taking derivative of e raised to x. The derivative of e raised to x will be e raised to x only. Therefore I get d2y by dx square, e raised to x is common. So here I get 2x plus 2 plus x square plus 2x. So I'll get d2y by dx square is equals to e raised to x into x square plus 4x plus 2. So this is the value of my second order derivative. Okay, this is the value of my second order derivative. I hope you have understood what is second order derivative. Let's see one more. Please take the screenshot. Please take the screenshot. Okay. Let's see one more. Again, there also I want to take second order derivative. Okay, I need to take second order derivative. This time I have x is equals to a cos cube theta, y is equals to b sin cube theta at theta is equals to pi by 4. And what I need to find out? I need to find out second order derivative. Okay, I need to find out second order derivative. So which means I want to find out d2y by dx square. But if you see this time, this is parametric over here. So again I have to go by parametric. Okay, logic only. My dy by dx will be nothing but dy by d theta into d theta by dx. So here my dx by d theta will be a is constant cos cube theta, so that will be 3 cos square theta into derivative of cos theta is minus sin theta. Similarly here dy by d theta is equals to b is constant, here that will be 3 sin square theta into derivative of sin theta is cos theta. So I'll substitute the value, therefore I'll get dy by dx is equal to dy by d theta, so that is 3b sin square theta into cos theta. into d theta by dx. So reciprocal of this. So 1 upon 3a minus this is cos square theta into sine of theta. So 3 gets cancelled. 1 cos theta gets cancelled. 1 sin theta gets cancelled. So I'll get dy by dx is equals to minus b by a into sine by cos, that is going to give me tan of theta. So I've got first order derivative. Now I need to find out second order derivative. So again I'll take a derivative. So d dx of dy by dx is equals to d dx of minus b by a tan of theta. So I'll get d2y by dx square is equals to minus b by a is constant. It will come outside derivative. Now derivative of tan theta is sec square theta into d theta by dx. Why? Because I'm taking derivative with respect to x and here I have theta. So again I will have to take derivative of theta. So I'll get d2y by dx square is equal to minus b by a. Sec square theta can be written as 1 upon cos square theta into d theta by dx. So I have here reciprocal of this. So minus 1 upon 3a sin theta into cos square theta. So I'll get d2y by dx square is equals to minus now will become plus b by a. So b by 3a square into 1 upon sin theta into 1 upon cos raised to 4 theta. Now next is saying theta is equal to pi by 4. So I'll substitute that value. So I'll get d2y by dx square is equals to b upon 3a square 1 upon sine of pi by 4 into 1 upon cos of pi by 4 the whole raised to 4. So d2y by dx square is equal to b upon 3a square. Sine of 45 degree is 1 by root 2. Cos of 45 degree is also 1 by root 2. The whole raised to 4. So I can write something like this also 1 by root 2 the whole square into 1 by root 2 the whole square. So I'll get d2y by dx square is equal to this root 2 will go up. So root 2 into b upon 3a square into 1 upon 1 by root 2, so that will become 1 by 2. 1 by root 2, so that will also become 1 by 2. So this 2 into 2, that is 4, that will also go up. So I'll get d2y by dx square is equal to 4 root 2b upon 3a square. So this is the value of my derivative. So similarly, we can find out nth order derivative also if it is asked. Everyone, please take the screenshot of this. Done. Okay, I hope everyone has taken this screenshot. Let's go for next numerical. Now, here next, if x is equals to sine of t y is equals to e raised to mt, then show that 1 minus x square into d2y by dx square minus x into dy by dx minus m square y equals to 0. Don't take it as a show that numerical. Actually, this type of numericals are asked in your exams. Okay, JEE exams. And instead of what I've written here, show that similar 4 options will be given to you in the question. Okay. Exactly same question, but instead of I have written show that, there will be 4 options which will be exactly similar, only some sign changes will be there, and exactly similar thing will be there. Okay, so this has come many a times in your exam. So these are important. So now if you see over here, you have one term as d2y by dx square, which gives you a hint that I have to take derivatives 2 times. So there is one way where we can find out value of dy by dx, d2y by dx square, and I can substitute in this equation, and I can see if I am getting LHS is equals to RHS. Or the second way is, while solving itself, we will do some kind of an adjustment and we can get this. So let's see by which method we will get this. So first it is parametric. So dy by dx will be equals to dy by dt into dt by dx. Now dx by dt will be derivative of sin s cos t, and dy by dt derivative of e raised to mt will be e raised to mt into m. Let's substitute the value over here. So I'll get dy by dx is equals to m into e raised to mt into 1 upon cos of t. Dy by dx is equals to m into e raised to mt 1 by cos is sec of t. This is the value of dy by dx. Now we can try to go by like this. I can multiply here. I have dy by dx. With that I have x over here. So I can multiply x over here, and then I can go for taking the derivative, or I can take derivative of this, find out d2y by dx square value, and then substitute over here. Okay, by any method we'll go. I'll try to go by this. I'll see the term what is there over here. So with dy by dx I have x. So I'll multiply x on both the sides, because I cannot bring anything from here, right? So x dy by dx is equals to x into m into e raised to mt into sec of t. Now if I want d2y by dx square, I have to take derivative with respect to x. So I'll write d dx of x into dy by dx is equals to d dx of m into x into e raised to mt into sec of t. So here also I will have to apply u into v. So if I take x common, x is constant, so derivative of this will be d2y by dx square plus, now I will take dy by dx is constant, so derivative of x will be 1 is equals to m is constant, it will come outside. Okay, integration derivative symbol, so I'll get d dx of, I can substitute the value of x, which is sine t. Okay, so I'll get sine t into e raised to mt into sec of t can again be written as 1 upon cos t. So I'll get x into d2y by dx square plus dy by dx is equals to m into d dx of sine by cos is tan of t into e raised to mt. So now I will take the derivative. So I'll get x into d2y by dx square plus dy by dx is equal to m into, here now I will apply u into v. So I'll take tan of t as constant. So e raised to m2 derivative will be e raised to m2 into m into dt by dx plus. Now I will keep e raised to mt as constant and I'll take derivative of tan of t. So that will be sec square t into dt by, sec square t into dt by dx. Why? Because I am taking derivative here with respect to x. So I'll get x into d2y by dx square plus dy by dx is equals to m into tan of t into e raised to m into dt by dx. So that is 1 upon cos t plus e raised to mt into sec square t into dt by dx. So that will be 1 upon cos t. So I'll get x into d2y by dx square plus dy by dx is equals to m into so let's see if I concentrate over here m into e raised to mt into 1 by cos t, similar term I am having here also. Okay, so if I just write this tan of t over here, so I have this, which is exactly over here. So instead of that, I can write dy by dx okay. Again, I can write here, if I take this m over here from here, so I'll get x by m dy by dx is equals to e raised to mt into sec of t. Okay, so same thing I can get over here. This sec square can be written as sec t into sec t. Now, here instead of e raised to mt, I can write x upon m. So I am going to do that only. I am going to write x upon m into 1 upon cos square t. Okay. So now I will get x d2 by dx square plus dy by dx. I multiply m inside, so m into tan of t into dy by dx plus m and m will get cancelled, so I will get x into 1 upon cos square t. So, cos t can be written as dx by dt. Again, I don't need t terms over there and I have to search something for that. Cos square can be written as 1 minus sin square. Tan can be written as sin by cos. Becoming a little bit complex. Okay, no worries. Let's take this over here. So I'll get x into d2y by dx square plus dy by dx. I'll take common. So what will remain inside is 1 minus m tan of t is equals to x in x upon cos square t can be written as 1 minus sin square t. And sin t is nothing but x. So that will become x upon 1 minus x square. Okay? So I will have to think something of this also, tan of t, which can be written as sin by cos. Any other possibility? Okay, no, I will have to simplify with that only. So I'll get x into d2y by dx square plus dy by dx into 1 minus m into tan of t can be written as sin of t upon cos of t, which is equals to x upon 1 minus x square. So I'll get x into d2y by dx square plus dy by dx into 1 minus m into x, because my sin t is x. Now cos t can be written as under root of 1 minus sin square x. So I will have to write under root of 1 minus x square. Okay? Equals to 1 upon under x upon under root of 1 minus x square. So I'll get x into d2y by dx square plus dy by dx into under root of 1 minus x square minus mx, the whole upon under root of 1 minus x square is equals to x upon, which can be written as further 1 minus x square into root of 1 minus x square. Okay, everyone, please take a screenshot up here because my board space is also done. Everyone, please take the screenshot. I hope everyone has taken the screenshot. I think so. Instead, we would have found out the value of, we had got over here dy by dx. Then that would have become easy. So dy by dx, here m into e raised to mt into sec of t. Then from here, if I would have found out d2y by dx square, then I would have got m e raised to mt into derivative of sec is sec x into tan x, sec t into tan of t, plus sec t as constant, so m into e raised to mt. I guess this would have become much more easier than you would have got as this. Then what you would have done, that you would have put the value of d2y by dx square over here, dy by dx value over here, okay, and you would have just taken this LHS, and then you would have solved it. Then you would have got it as 0. Then it was easy to prove LHS is equals to RHS. Sometimes it doesn't strike in one go, because this is becoming much complex. Hope everyone is taking the screenshot. Everyone, please try this as a homework. Okay. Everyone, please try this as homework. Anyways, the time is also done. Okay. Have a nice day ahead.